Uh, when he's see the difference when he puts what happens to the adding these weights. I'm adding these weights. So I'm adding the weights there. So what am I doing? I'm increasing the pressure because force is equal pressure is equal to force upon area. So area is constant, so I increase this, so the pressure increases. So then it comes down, is applying more force, it comes down, and the gas molecules which are always going up and hitting and coming down, they were moving with some velocity. Now I have not, in the first case I have not raised the temperature, so this velocity remains same. But when I decrease the distance, the L is reduced. So velocity is distance by time. Of course, it covers twice the distance in one collision. So if I'm decreasing this, I am this is constant. This is constant because this is dependent on temperature. This, if the temperature not changing, this is not changing. But if I reduce the distance, then this will also reduce, time reduces. So the frequency of collision increases, frequency of collision increases. So this increases and this increases, uh, the momentum change, the number of times the momentum change happens increases. That means the force increases, and that means the pressure increases. And a time comes when the pressure here and the pressure outside is balanced, and then it will stop. Now, if you do the opposite, you raise the temperature. He says, I am rising, heating it up. Now, if I heat this up, then something else happens. This time the now the weight is exterior pressure is same. So in the other part I have this the exterior pressure is in the new position, let this be the new position, and I heat it, I start heating it. So I am heating it, this is energy coming. So what SM energy will increase, so kinetic energy will increase, so half mv square will increase. So mass can't increase. So V has velocity is increasing, the speed increases. Now the speed increases, the distance. Now again V is increased. So 2L by T, the T is same. So if this is increased, then again this will decrease because this is constant now. This is constant. So there, the if the this is the time will decrease again. The collision frequency of collision increases, moment, and now velocity is also increasing. So two things happen now: frequency of collision is increasing, and the momentum change is increasing. Momentum change, both are increasing. Here only one thing was increasing, the frequency, uh, and the number of momentum change was increasing. But here the per momentum change also increases and the frequency also double things are happening. So then what happens is this pressure force increases, the pressure increases, and it starts going up. When it starts going up, it balances the outward force at this thing. And when that happens, what happens then that the length is now increasing, 2L is increasing. So now velocity, if this increases, now the velocity, the everything will become because the length is increasing, the time collision, this will also increase. Because now this is increase, this has to increase, because this now can't increase because the temperature has been raised and it is fixed. We are not heating it anymore. If we heat it continuously, it will keep on going up. But now this is constant. So if this is increasing, this has to increase. So once the time increases, the number of frequency of collisions falls down. And the momentum change also is constant. So now the pressure force will decrease and the pressure will decrease and it will become equal to the outside pressure and it will stop. So everywhere, you have to be very specific of what's happening. In temperature, what is happening? In weight, what is happening? And what is happening to the length, the momentum change, and the pressure and the force, everything. What is constant, what is not constant.